So we need to write an ionic equation for nitric acid reacting with sodium carbonate. Okay, so the rule for ionic equations is if a substance doesn't change its charge or its state, then we don't have to write it. So we only write substances that change their charge or their state. So to do this, it would be helpful if we write some charges on the ions in this equation. So sodium carbonate to start with. Well, sodium is there, is a metal, and it's in group 1 of the periodic table, so it's got 1 electron in its outer shell, so it forms a 1 positive charge. Okay, now it helps if you know the carbonate ion charge. It's a common ion, anion. Helps if we know it. Having said that, we can work it out if we don't know it, because it's got 2 sodiums, so 2 positive, so just the 1 carbonate ion, that's going to be the 2 negative ion. Nitric acid, well, that's hydrogenized acid, and there's 1 hydrogen ion and 1 nitrate ion, so the nitrate has to be a single negative charge. Again here, sodium is in an ionic compound, metal and non-metal, ionic. Sodium always forms positive ions, the nitrate forms negative ions. Carbon dioxide is covalent, therefore it doesn't form ions, and water here as well, also covalent. Okay, so no ions there. Right, so sodium, Na positive aqueous. So that's the charge on the ion and that's its state. And here it's Na positive aqueous. So we can cross that out. That's what we call a spectator ion, not playing part in the equation. The carbonate ion turns into carbon dioxide, so that's definitely changing, we're keeping that. The hydrogen ion turns into water, so that's changed from aqueous and charged hydrogen ions to water, so we're definitely keeping that. The nitrate ion, NO3 minus aqueous, NO3 minus aqueous, so that hasn't changed. Let's cross that one out, not keeping that one. Okay, so now we just need to write out what we haven't crossed out. So carbonate ion, CO3, 2 minus aqueous. Now we do include the charges here, if we've only got half of that. And likewise here, 2 hydrogen ions, 2 hydrogen ions. And then that's going to make, we're not writing any of that, so carbon dioxide and water. Let's put some state symbols in just to finish it off. Liquid, gas, was aqueous, and that's aqueous as well. Right, and there's our equation. All these questions on elshamhighchemistry.com.